Good evening, everyone. I hope you are able to see the screen. Can someone confirm if they're able to see the slides show?
Yes, it is
Yes.
visible.
Yeah. Thank you. Thank you. Yeah. Just we'll wait for one more minute, and then we will start the class uh, so that few more people can join. So
Is your screen currently shared?
yes, yes. Are you not able to see the
No,
screen?
I can't see the screen currently. It was visible a little earlier, but
Uh,
not now.
uh, Maybe you can just log off and join back.
Okay, okay.
Yeah. Yeah, so we can start the class now. So, good evening, everyone. Welcome to the NPTEL online certification course on water and wastewater treatment. So, we will be having the problem solving and doubt clarification sessions every Tuesday from 7 to 9 p.m. And I am the teaching assistant. My name is Akash Saha, and I'm a PMR scholar at the Department of Civil Engineering at IIT Madras, where I'm pursuing my PhD in environmental engineering. So I'll be helping out you with regarding any doubts or clarifications required throughout the course. And in these sessions, we will be solving basically some objective type of questions regarding the contents of the lectures that have been shared throughout the week. So every week we will be from the NPTEL team, they will be sharing a few videos uh, on some particular topics, and then at the end of the week on Tuesday we will be having that problem solving and doubt clarification session. And as you all know, the course instructor is Dr. Bhanu Prakash from IIT Roorkee. Okay, so in this water and wastewater treatment, mostly we'll be solving numerical type of problems, but today might not be the case because we will be just introducing the concepts and starting with the subject. But later, mostly we'll be solving numerical types but objectives, and at the end of the sessions, before the end of the session, we'll be also solving some subjective type of questions, because though they will be not a part of the exam, but they will help you to understand the concepts better, and through one subjective type of problem we'll be able to solve many objective type of problems. So that is my idea. So if you see this course, actually this is divided into water treatment and wastewater treatment. So we'll start with the water treatment first, and no, we will start with the wastewater treatment first, and then we will move to the water treatment. So today we'll be just going through the contents of week 1, which will comprise of the importance of water and wastewater treatment, where we'll be discussing about various kind of waterborne diseases, what is the germ theory and the cholera epidemic. And then we'll be talking about some life expectancy and real world scenarios, and then we'll move on to the concepts of water and wastewater treatment plant, what how the schematic looks, and what are the basic functions of each of the processes, and then some fundamentals, because before solving any type of numericals, we should know how to deal with the concentrations, conversions, how the material flows from one system to another, and how to balance them. So these are some of the basic concepts, and I hope that you have gone through the lectures of week one. So we'll be directly starting with the problems, and then we will discuss the answers as and when required. Okay, so let's start with the first problem. I request everyone to be active in this session, and you can answer in the chat box directly the correct solution, and then we can discuss how it like how it goes. Okay, so the first question is, which of the following are waterborne diseases? So we have four options here: cholera, asthma, influenza, and typhoid. So which of them are waterborne diseases?
D.
D. Okay, anyone else?
Typhoid.
You can just you know don't have to unmute and speak. You can just type the answer in the chat box. That would be much easier. Otherwise, again and again you have unmute and unmute. So I'm getting some answers, and always also remember that it is not necessary that only one of the answer is correct. It can be more than one correct answer. Okay. Yeah, so I'm getting mixed answer. Many people are saying it as D and some it as A. So yes, actually the correct answer is A and D. Both cholera and typhoid are correct, are waterborne diseases. Okay, so these diseases are caused due to the exposure to contaminated water and can be caused by various kind of bacteria, virus, protozoa, and toxins. Asthma is not waterborne. It is considered an airborne disease, okay, because it is triggered by the allergens in the air, okay, and not through water. And influenza is primarily spread by the air from infected people through coughing, sneezing, and talking. So when we talk about any waterborne diseases, they are there are other kinds of diseases also. So we have basically four kinds of diseases. One is waterborne, which we just talked about, which is caused by the drinking water contaminated by human or animal feces. Okay, these which contains any kind of pathogenic organisms. So these are called waterborne diseases. For example, cholera. And then there are water-based diseases, which are caused by the parasites that live in water and infect the humans through skin or through skin contact or injections. Okay, so schistosomiasis is one of the example. So just be careful with the names. And then there is another class of water related vector borne. So diseases like malaria, which are spread through mosquitoes, which are known as vectors, okay, that breed in or near the water. So these are water related vector borne diseases. And then water source or water washed diseases, so which are caused by due to the poor personal hygienic conditions, or eye or skin contact with the contaminated water. So, for example, there is a disease called trachoma. Okay, so this is a brief overview about the different kinds of water-based diseases. Right? We will move forward. And at any point of time, if you are uh, facing that I'm going too fast, then you can stop me. We can go back to that question and discuss. Okay, you can just raise your hand or just unmute and speak. Okay, the next problem. In the following figure, the course of a river is shown. As it passes through different areas, it accumulates different types of contaminants. So we have part A, an agricultural land, then a forest, and then a urban built up area. So you have to match the location with the kind of contaminants that it can have. Okay, so suppose somewhere we can find pathogens, suspended solids, nutrients, heavy metals, organic matter. In some places we can find nutrients, heavy metals, and organic matter. And in some places we can just get organic matter and sediments. So what do you think is the correct answer? Others can also try. 3. Okay, so everyone is giving different answers. Okay, I'll wait for some more answers. Okay, option 2. Okay, so majority is with option 2. So just on a different note, I would request everyone to fill this spreadsheet that I've just shared with you in the chat box. So you can share your name and email ID. Just these two are the basic information I need, so that if any additional materials or change in timings of the classes or any other related information to the course, if I want to give you, I can give directly to you through your mails. So I just want to uh, write your names and the email IDs in this Google spreadsheet. Okay, so additional resources, if I want to share, I can easily share it with you. So just please open this spreadsheet and fill in your details. So it will be helpful for me. Okay, share request. Just a second. Yeah, I think everyone will be now ask will be now able to access. Yeah, I've given access to everyone. Just open the link again. Yeah. Yeah, coming back to the question. So as majority of you have indicated the right answer to be option 2. So yes, it is the correct answer. So A, for any agricultural land, we will be basically getting the nutrients, okay, either through the surface runoff from the pesticides or the fertilizers that we are inputting in the agricultural field. So a lot of nutrients can come up, also heavy metals and organic matter. Okay, and then for B, that is a forest. From forest, we can get all kinds of, uh, I would say mostly organic matter and sediments. Okay, because heavy metals, we don't think so that directly from the forest we will be getting, because those are mostly anthropogenic activities. And then for option C, that is an urban built up area, we can get all sorts of pathogens, sediment, suspended solids, nutrients, heavy metals, and organic matter, everything. Okay, so option 2 is the correct answer here. I think it's very easy. There is nothing much to discuss in this. Okay, we'll move forward. Next question. It says that adequate wastewater treatment can contribute to achieving which of the following UN Sustainable Development Goals, or we call it as SDGs. Okay, so SDG 11, Sustainable Cities and Communities, SDG 6, Clean Water and Sanitation, 4, Quality Education, and 3, Good Health and Well-being. So which of the following is the correct answer here? Okay, option B. Okay, A, B, and D. Anyone else? I request everyone to please mute yourself so that it doesn't disturb others. Yeah, thank you. So here also multiple answers can be correct. Not necessarily only one answer is correct. So even if you don't know how the wastewater treatment is directly related to the SDGs, we can just uh, see the objective of the SDG, and then we can find out. So first one says sustainable cities and communities. So obviously, if we want to make the city sustainable, then the water conservation, okay, and the use should be managed properly. So a lot of water, a lot of wastewater is generated. Okay, so if we can reuse it by treatment in different industries or agricultural or even for domestic purpose, then it will be more sustainable for the environment. So definitely SDGs 11 will be contributing factor. Then what SDG 6, as it directly says, clean water and sanitation. So definitely B will be the right answer, because if we treat wastewater properly up to the potable limit, then we can even use it for drinking. Okay, but the treatment has to be of higher efficiency. And then quality education, no, not necessarily, because education, I don't think it will be related to the wastewater treatment. But as DG6, as it says, good health and being. So always water and sanitation goes hand in hand. If the water is not contaminated and the sanitation issues are fine, then it will directly affect the health. Okay, so water sanitation directly affects the health of the human and even the animals also. So option A, B, and D, all of them are correct. So here I have given the snapshot of all the 17 SDGs. So as per the UN, there are 17 SDGs. So water is somewhere or the other linked with many of these SDGs, not only these three. I think more than six SDGs, the water is related. So you can just make a note of it. Okay, right. So we'll move to the next problem. Hardness in water causes joint related issues, digestive issues, fluorosis, cholera. So when we say hardness, can someone define hardness in just two words? If we want to say hardness, can someone define hardness is just two words? Calcium and magnesium salts. Okay. Calcium and magnesium, yes, it imparts hardness, but that is not the exact definition. Dissolved salts, that is also partly right, because not all salts will impart hardness. If I just want to sum up hardness in two words, how it will be? You have to be very specific here. So though calcium and magnesium are correct and they impart hardness, but that is a part of hardness, not the overall picture. So it is something to do with the valency. Carbonate and non-carbonate is also a type. So when we say hardness, we say that the presence of any multivalent cation. So the important two words are multivalent cation. So any kind of multivalent cation will impart hardness. Okay, so it's not only calcium and magnesium, it can be anything starting from ferric, aluminium, okay, strontium, whatever. Though in our water systems, the percentage of calcium and magnesium is very high as compared to the other multivalent cations. So for ease of our calculations, we take only calcium and magnesium into consideration. So most of the people think that only calcium and magnesium imparts hardness. But though it is partly true, but the actual definition is any multivalent cation will impart hardness in water. And then obviously the cation has to be combined with some kind of anion. So there the carbonate, or the sulfates, chlorides will come into the picture. But by definition, only the multivalent cations impart the hardness. I hope this is clear to all of you. So coming back to the question, so hardness in water causes different type of problems. One of the major problem is the scaling. Okay, due to which the effective area of the pipe reduces. So case scaling is a very big issue. Apart from that, option A and option B are also true. It causes joint related issues and digestive issues also. So the fluorosis is caused by fluoride, and then we have cholera, which is caused by, as we saw in the first question, it's a water disease. Okay, waterborne disease. So hardness will cause joint related and digestive issues. Going to the next problem. Groundwater of a tier 2 town was found to be contaminated with fecal coliforms. What may be the possible reason for this? Fecal coliforms are naturally occurring in soil, rainwater infiltration, leaching of sewage from septic tanks, collecting fecal waste from individual households, and then infiltration from irrigated agricultural lands. Option A and C. So here you have to be careful with two things. One of them is that it's a tier 2 town. Okay, so this can affect the type of problem that can arise. And other thing is the presence of fecal coliform. So fecal coliform will be present in only certain conditions, not everywhere. So you have to go with the most possible reason. Most possible reason. Yes. So I think many people are answering it as correctly as option C. So if you see for any tier 2 town, mostly there will be many septic tanks present in the nearby areas. So from those septic tanks, it will carry a lot of pathogens. Okay, so wherever these pathogens are there in the feces, there will be the presence of the fecal coliforms. Okay, so coliforms are just an indicator type of organism. Okay, it doesn't not it doesn't mean that they will cause harm uh, to the humans. These are basically indicator type of organisms, and these are present wherever the pathogens are present, which affects the humans. Okay, so the correct option is leaching of this sewage from the septic tanks, collecting fecal waste from individual households, right? Because in rainwater we won't see any fecal coliform, neither from the infiltration of any agricultural irrigated lands. So we previously discussed about what kind of different contaminants that can be present from different kind of areas. So pathogens or fecal coliforms comes from the urban or town kind of area. So right. So option C is the correct answer here. Okay, so leaching. So by leaching we mean that it's a slow process where the wastewater seeps through the system. Okay, so from the septic tank. So ideally the septic tank should be closed from the bottom so that there is no seepage. But most of the time in India, to save some amount of money, they won't seal the bottom part, and many a times these pathogens may seep through the ground. Okay, so it's a big issue. Moving forward. Okay, so now here we are talking different types of reactors. So which type of reactor is a closed system where the concentration changes only due to the reaction? Okay, so there are various kinds of systems like a batch reactor, a continuously stirred tank reactor, which is also called as a CSTR, or a plug flow reactor. So which of them do you think the concentrations changes only due to the reaction? Okay, so you have to be very specific. So there can be many ways through which the reaction can change or the concentration can change. So where does the concentration changes only due to the reaction? So I hope you are well aware of the different kinds of the reactors that we generally use in any kind of wastewater process. I think I didn't get the correct answer yet. Everyone is. So first of all, one keyword here is it's a closed system. Okay. Once the contents are put inside the reactor, it will be closed and then we let the reaction to happen. Yeah. Uh, Mr. Maniklal Sahu, you want to say something?
Sir, I think these are the anaerobic system.
No, here we are not talking about aerobic or anaerobic system. It's
Yeah.
it is a different type of reactors. So we have basically a
Okay, sir.
batch reactor, a CSTR, and a plug flow reactor. We'll discuss these things more in detail in the next upcoming classes. But for the basic, you should know that like okay. So let me give some information regarding this because I think most of the people are going wrong in this. Okay, so suppose we have a reactor here and we have some stirrer inside. So in some reactors, what we do, we will put all the constituents inside the reactor. Okay, we have put all the constituents and then we will close it. We will close it and then we will mix it properly for some time and then take out. So suppose the input concentration was C naught, the final concentration will be something C. Okay, so there is no continuous inflow or outflow. So once we put in all the contents in the system, then we will close it, let the reaction to happen, and then we will take out. Okay, so the reaction happens inside. Then there is another type of system where in the reactor there is a continuous inflow and there is a continuous outflow, and inside that the mixing is also happening. Okay, there is a continuous inflow, so we will say suppose some flow is coming with a discharge of q naught, and the initial concentration was C naught. Okay, then it is getting mixed and some amount is after that, after mixing, it is coming out. So maybe the same amount of q naught is coming out. Okay, but now the concentration will be C. And also you have to keep in mind the same concentration, whatever is coming out, will be the concentration inside the reactor also. Okay, so input concentration C naught will be different from the concentration inside the reactor and whatever is coming out. Okay, so this is the second type of reactor. This is the first type of reactor, then this is the second type of reactor. The third type of reactor is it's generally a longer kind of section will be there. Okay, and then the constituents will be moving from one point to the other. Like suppose this is one part, then it will move to the next part. It is continuously flowing. Okay, continuously flowing. So there is a continuous input and then there is a continuous output. Okay, but it is moving laterally. Okay, so this is this reactor is equivalent to, suppose I put many this of type 2 reactors, type where there is one input is coming, it is going out, going to the other one, going out, going to the other one, like this. Okay, so these two are almost same. These two are same. Okay, so we have these kind of three reactors are there. So this first one is called as batch reactor. The second one is called continuously stirred type reactor, and the third one where the liquid moves laterally is called as a plug flow reactor. Why this is called a plug flow reactor? Because these things, this part, these things are known as some plugs. So there are infinitely many plugs inside the reactor which is moving laterally. So if we put infinite number of stirred continuous stirred type reactors one after the other, it will behave as a plug flow reactor. Okay, so these are the three reactors. We will discuss more these things in detail in the upcoming class where we'll do the mass balance and all those things. Okay, so let's not worry about it now. So coming back to the question. So a type of reactor which is closed where the concentration changes only due to the reaction is a batch reactor. Okay, and the other type of reactors are continuous. Okay, inflow is also coming, outflow is also happening, and the reaction is also happening inside the reactor. I hope this is clear for now. Is anyone having any doubt? Okay, and one more thing, like closing the reactor doesn't mean that it is becoming anaerobic. Okay, we can supply oxygen inside the reactor also to keep it aerobic. So not necessarily all closed systems are anaerobic. Next, advection is bulk movement of fluid in one direction. Is it true or false? So we have different properties of fluid. One of them is advection, one of them is dispersion, and then another one is diffusion. So these are three basic properties of fluid. Yes, you can speak up.
I think, sir, this is true.
This is true. Okay. Yeah, we will let others to also answer. And everyone, just you can just type in the chat box. You don't have to unmute every time. You can just type it in the chat box. Okay, so this is a very direct problem, advection. So yes, this is true. It's the bulk movement of fluid in one direction. So advection is the transport of a substance or a quantity, okay, by bulk motion of fluid. The properties of that substance are carried with it. Okay, so it simply means that suppose that there is a okay 1 minute. Suppose that we have a stretch of river, okay, which is flowing in this direction, which is flowing in this direction. Let me suppose I dropped something of concentration C here at a location, suppose 0, at a location 0. Okay, now if it moves to a location of suppose 1 kilometer, so after that also the concentration will remain the same. The concentration of that particle of that thing will remain the same. It will be just transport due to the movement of the fluid, by the bulk transport of the fluid. Okay, there will be no change in concentration. Why the concentration changes most of the time is due to the reaction. Okay, there can be some kind of microbial degradation, there can be some kind of photochemical degradation, or there can be some kind of chemical degradation inside the water. Okay, so most of the time we have we have a tendency to think that the concentration changes, but it doesn't happen due to advection. Advection simply transports the same concentration from one point to another due to the bulk movement of the fluid, right? It's like just dropping a ball from one point, a plastic ball on in a river. After 1 kilometer also, the plastic ball remains the same. Okay, it will be floating, right? So this is advection. Whereas the same thing, if suppose there is a gaseous particle, it will slowly radiate in a, it will slowly radiate around the circumference. Okay, and this is called as diffusion. This is called a diffusion. This happens not due to the bulk movement of the air. This happens due to concentration gradient. This happens due to the concentration gradient. What does that mean? It means that the concentration like moves from a higher concentration to a lower concentration, like that. Okay, so due to the difference in the concentration of the two places, the diffusion happens. But this happens in a circumferential uh, area. Okay, so these are basic two types of properties, be it in fluid or in air. So air or water, both are fluids. So air or water, anything. Moving to the next problem. Equalization of the influent flow of wastewater treatment plant is done to prevent shock loading. Is it true or false? Anyone else? Yeah. So as most of you are answering it as true, so this is correct. So equalization, so you know that when the wastewater influent comes into any sewage treatment plants, so after the basic screening or the grit removal, we have an equalization tanks. Okay, so just a minute. Okay, so why it is required? So it is used to temporarily store the wastewater. Okay, and it allows uniform flow rate to go through to the other processes which are there subsequently. Okay, so it prevents, suppose during the overall day, the both the quantity and the concentration of the wastewater that is coming into the system will be different. It won't be the same all the time. Okay, so the bacteria or the microbes which are present in the activated sludge process system might not face any problem due to shock loading. Suppose a higher concentration of a influent comes in suddenly, so it might affect the microbes. So that's why we put a equalization tank before it reaches the ASP system, so that there is a uniform quantity as well as quality, that is the concentration that the system gets. Okay, so that's why equalization is very much important in any wastewater treatment system. Okay, so both the flow rate and the concentrations are averaged out over time. It is used for a temporary storage. Next question. I hope everyone is clear. If I'm going too fast, please let me know. I think these are very simple problems, so not many people are having any doubt. Moving forward, the compound used by Dr. John Snow to curb cholera is A or an dash agent. So select the correct option: oxidizing, reducing, biological, or none of the above. So what is that compound that has been used to curb cholera? Can someone tell me? What is that particular compound we are talking about? I can't hear you. Anyone? I think someone unmuted and spoke up.
Sir, what you have asked, please tell me.
Yeah, I'm asking what is that particular compound that we are talking about here, which was
It is
used to.
it is John Snow curb. It is John Snow curb we are talking about.
No, no, I'm talking about the compound.
Biological.
Oh, sir, I think the correct answer is biological.
No. So we are talking.
Oxidizing.
Yeah, oxidizing is correct. Okay, oxidizing is correct. But what is the name of the compound or the what is the substance that has been used to curb cholera by Dr. John Snow? Anesthetic. Yeah. So chlorine is the correct answer. Yes. Not chloride, it will be chlorine because in chloride form it won't be that the disinfection won't be there. So in chlorine. Okay, so it's an oxidizing agent. So what happens is like chlorine is highly electronegative and it can easily take out electrons from other atoms and convert into ions. So that's why it is a strong oxidizing agent. So this was the compound that has been used by Dr. John Snow for cholera. Okay, how chlorine can be helpful in curbing cholera? Can someone tell me? We have talked about cholera. So how chlorine will be helpful in curbing cholera?
Sir, this is disinfection reagent.
Yeah,
Chlorine is.
yes, that is correct. So chlorine is a very good disinfecting agent. So it will kill all the kind of microbes present in the system. Okay, and how does it kill the microbes? By oxidizing them. So that's why it's a very strong oxidizing agent, right? So that is the reason. Next, select the correct option for the statement given below. Germ theory states that certain diseases are caused by the invasion of the body by microbes, which are too small to be seen except through a microscope. So, what do you think? Is it correct?
True, true.
True. This is very easy. I think there is nothing much to discuss in this. So, this is true. Okay, I'm not discussing it much. Next, which of the following reactor types provides the highest conversion per unit volume for a first order reaction? So here again we are talking about those three reactors that we just discussed. So one is the batch reactor, one is the CSTR, and one is the PFR. So what the question is asking, suppose we have the same volume or 1 meter cube volume of each of these reactor, be it a batch, CSTR or PFR. In which of these reactor the conversion rate will be higher? So that means if I am putting some 100 milligram per liter of contaminant, where the degradation will be the most or the change in concentration will be the most if the volume is same for all the reactors.
Batch reactor.
Batch reactor, no, that is not the correct answer.
Sir, I think option B, CSTR.
Uh,
Well, I guess the FR is the correct one since you said it has infinity reactors there, like a plug.
yes. So you are absolutely correct. So PFR is the correct answer. Okay, so PFR is the correct answer. I just wanted to, by saying that it has infinitely many CSTRs, it means that we consider each of the plug as a CSTR. It doesn't mean that it has infinitely number of CSTR, but we call each plug of the water as a CSTR. So can you please mute yourself? Yeah, thank you. So in the PFR, the reactants move in unidirectional flow without any back mixing. Okay. So as the reactants flow through the reactor, the concentration decreases progressively along the length. Okay. So the concentration gradient is the most in the case of a PFR. Right. We will discuss more. We will see the equations, how it is affecting, okay, the concentration. Don't worry about it. If you are not clear right now, it will be clear in the next session, in the next week. Okay, so don't worry about that. So for now, you just remember that the conversion rate is the highest for any PFR as compared to the other reactors per unit volume. Okay, because if the volume changes, then is a different game. Okay, so if you consider the same volume for all the reactors, PFR is the best performing reactor. Next, select the correct statements regarding the acceptable limits for drinking water in the Indian standards. So we have pH range 6.5 to 8.5.
A is the correct answer. pH range is 6.5 to 8.5.
Yes, I think there are more correct answers than one. So what is the
Sir,
other
A and C.
A
A
and
and C.
A and C? Yes, definitely. So both are correct. So can someone correct me about the B and D option? So what should be the TDS range? Can someone tell me? What should be the TDS range in the drinking water limit standards?
250 mg per liter TDS
No.
should be less than 250.
So as per the
If
Indian,
I'm not,
sorry,
yeah, the TDS, the total dissolved solids. If I'm not wrong, I think it should be nil.
no, it is not the case. So TDS,
500.
yes, yes,
500
yes. So TDS should be
C.
less than or equal to 500, and if there is another clause, so if you see the Indian standards for drinking water, there is an accept permissible limit which is 500, and then there is a accept another clause for the absence of any alternate source. Suppose you don't have any other alternate source, then the acceptable limit is less than 2000. Okay, so it is written like this. I will just show you. Yeah, so TDS should be less than or equal to 500 milligram per liter, but it can be also less than 2000 milligram per liter in the absence of any alternate source, right? Hardness should be less than 200 milligram per liter, as you already pointed out, but in the absence of any alternate source, it should be less than 600 milligram per liter. Nitrates should be less than or equal to 45 milligram per liter, and there is no relaxation for any alternate source. Okay, so these are the cases. Apart from this, there are around 80 plus other parameters, okay, drinking water parameters, which you have to be careful for about the Indian standards. Can someone tell me what is the code for the Indian standard for drinking water? What is the number? So that others can also.
7.
1050.
10500.
Yes, 500.
500. It's a 2012 drinking water standard. So 10500. Another question I would like to ask at this point is, what do you think is the most important parameter for drinking water standards? We have so many different type of parameters: physical, chemical, radioactive, biological. There are n number of drinking water parameters. But if you are given an option that one parameter for which there is no relaxation at all, which one is that?
pH range should be 6.5 to 8.5.
pH range is not that important, like as compared to the
The
others.
dissolved oxygen.
Yes,
Dissolved oxygen should be
no, not dissolve. Yeah, someone in the chat box has rightly
only
answered.
form. Only form will be zero.
Yes, it should
BOD
be
should be
zero the
less.
biological.
Yeah, the presence
Okay.
of vehicles.
Yes, so it should be 0 mpn per 100 milligram per 100 ml. Okay, so unit that we use is mpn by 100 milliliter. Okay, milliliter. So it should be 0. There is no relaxation for that. So if someone has asked like what is the most important parameter for the drinking water standard, it should be the coliforms. Okay, biological, right? We'll move forward. Yeah, all those who have joined later, I request that you please fill this Google sheet which I have just shared. Who have already fill in your details, you don't have to worry. But those who have joined after some time, please open this link and fill in your details. So I will be able to send any type of additional resources directly to you through the mail ID. Okay, just your affiliation and all is not very important. You can put it, or else I just basically need the uh, email IDs. Okay, so just please fill in your details. Right? For others, let us move forward. So today basically we are only doing, link is not opening. No, I think everyone is able to access it. Yeah, please try again. I think it's opening because I see others filling up the form now. Please try again. Okay, the next problem. Total coliforms are a possible indicator of fecal contamination or chemical contamination.
Sir, option A is right. Fecal contamination.
Yes.
Yeah, fecal contamination.
Yes, so that is correct. So that is correct because very easy fecal contamination.
Yeah.
Okay, so total coliform counts give the general indication of the sanitation condition. Okay, and it includes bacteria that are found in the soil, in water that has been influenced by surface water, human or animal waste. Okay, so it's a possible indicator of fecal contamination. Which of the following a typical sand filter cannot remove at all? Okay, so you have to tell me which of them cannot be removed by the typical sand filter.
Algae.
Sir, I think option A, viruses.
Yes, that is correct because viruses are too small to be removed by the pores of the sand filter, whereas much of the bacteria, algae, and cysts can be removed by the pore size of the typical sand filter. For viruses, we need much lower pore size, which can be removed through some kind of advanced filters or membranes. Okay, so I hope this is clear. Okay, so it has to be in the nanometer range, then only it can be removed. Match the type of treatment with their primary function. So we have preliminary treatment, disinfection treatment, primary treatment, and secondary treatment. So please match with the corresponding primary function. Anyone else?
Sir, I think this is option A.
Okay. Yeah, so most of you are answering to the option A. So let's see. So first,
Yes.
in any wastewater treatment plant, we go for the preliminary treatment. So preliminary treatment includes the screening or the grit chamber, oil and grease, all these things. So these removes the bigger size particles. Okay, whatever bigger size particles are there are removed by the preliminary treatment. Then we have the primary treatment where the suspended solids, okay, smaller than the smaller than the earlier particles, like mostly it will be in the suspended form. So all the suspended solids, and when we are removing through primary treatment these suspended solids, some part of organics are also removed, around 30% will be also removed. So this is the primary treatment. Then we go to the secondary treatment, where majorly the removal of organics happen. Okay, so we indicate organics through the BOD, biochemical oxygen demand. So uh, so it generally involves the processes like activation sludge process or MBBR or MBR. So all there are various kinds of process that we will look throughout the course. And then at last we have to go for disinfection, because a lot of pathogens are present, as we all know. So it has to be removed from the system. So the final one is the disinfection. Okay, and there is also tertiary treatment. So by tertiary treatment we mean removal of any kinds of nutrients, emerging contaminants, heavy metals, everything, pesticides, all those things comes under the tertiary treatment. Okay, so basically in most of the sewage treatment plant we will see the preliminary, primary, secondary and disinfection. But in some advanced treatment plants we also see a lot of tertiary treatment. And in this day and age it is very much required, because we want to reuse this wastewater for different purposes. So tertiary treatment are also being utilized effectively in many of the treatment plants. Okay, okay, so here is a small, very small numerical that uh, you can try. So it is given that the concentration of calcium carbonate is 250 milligram per liter. Now it has to be written in various forms. So 250 milligram per liter. So what is the concentration in ppm or parts per million? Equivalent concentration in milliequivalent per liter. Concentration is ppb, that is parts per billion, or the molar concentration in millimolar per liter. Okay, so the main concentration, the actual concentration that is given is the 250 milligram per liter of calcium carbonate. So now you have to know how to convert into various units. So unit conversion. So please try it out. Take out your pens and papers and let me know the correct answer. Option B. Okay. Anyone else? Please try it out. Others also please try it out. If someone is facing a problem, don't worry. We will see the solution to how to convert this concentration in different forms.
Sir, please explain me. I'm getting confused with this problem.
Yeah. Just wait for 2 minutes. We'll see
Okay,
all the
okay,
answers and then we will discuss. Don't worry. We will discuss
okay.
all of the answers in detail. Whichever questions that I am projecting now, we will discuss everything in detail. So as many of you have pointed it out, the correct answer is option B. Okay, so let's see how. So we have to remember a few points. So we should know that 1 ppm, or we call it as parts per million, Okay, 1 ppm is equal to 1 milligram per liter. So that is the first thing, 1 milligram per liter. Okay, so the concentration that is given in the question is 250 milligram per liter of calcium carbonate, right? So if 1 milligram of calcium carbonate is equal to 1 ppm of calcium carbonate, then 250 milligram of calcium carbonate will be equal to 250 ppm. Okay, so the first one is 250 ppm, right? So one will match with B. Then what is the equivalent concentration in milliequivalents per liter? Milliequivalent per liter. Okay, so first of all, we have to know what is the molar mass of calcium carbonate. So calcium carbonate is CaCO3. So what is the molar mass? Molar mass, how to calculate the molar mass? So calcium, it's 40 plus 12 for carbon, and for oxygen is 16 into 3. Okay, so it is 100. Okay, so 100 gram per mole. So 1 mole of calcium carbonate contains 100 gram. Okay, roughly. So this is the case. So what will be the equivalent weight of? So then first we will find the molar mass, then we will find out the equivalent weight. So what is the equivalent weight of calcium carbonate? So it is the molar mass divided by combining capacity. Combining capacity. So this combining capacity can be anything like the charge or the electrons giving capacity or the proton taking capacity, anything. Okay, so molar mass divided by combining capacity. So molar mass is 100. What is the combining capacity of calcium carbonate? It is 2. So equivalent weight is,
2.
yeah, equivalent weight is 50 gram per equivalence. Okay, 50
Equivalence.
grams per equivalence. Okay, so now we have to find out CO3 in milli equivalence per liter. Okay, okay, so we know that we have 250 milligram per liter of calcium carbonate. Okay, we will simply divide it by 50 gram per equivalence. Okay, just a minute, someone is trying to join. Okay, now to convert milligram to gram, we will just multiply it with 1000. Okay, to change the gram to milligram. So the final answer will be 5 milli equivalents per liter, because we need the answer in milli equivalents. So that's why this factor is coming in. Okay, so 250 milligram per liter of CaCO3 divided by 50 gram per equivalence, right? So 5 milli equivalents per liter. Next thing, so now they are asking in ppb. So always remember 1 ppm is equal to 1000 ppb. What is ppb? ppb is parts per
Billion.
billion. Yeah, parts per billion. So for 250 milligram per liter of calcium carbonate is equal to 250 ppm of calcium carbonate, which is equal to 250 into 1000 ppb. So that is 250,000. Okay, ppb of calcium carbonate. So this is the third answer. Now fourth, I leave it for you. You can simply solve. I will just say 1 mole is equal to 100 gram, right? 1 mole is 100 gram of calcium carbonate. So for 1 millimolar, it is 1 mole by 1000, because 1 millimolar is there. So 1 mole by 1000. So what will be the correct answer here? What will be the correct answer here? We have 250 milligram per liter. Can someone explain who has answered it correctly? How to solve this? What is molarity? Hello, am I audible?
Yes, sir. Please continue.
Yeah. Uh, yes, sorry, just a minute. I thought there was some problem with the connection. So yeah. So what is molarity? Molarity is nothing but moles per liter, right? Moles of per liter. Now we know that we have
250 by 100.
yes, we have 250 milligrams per liter. Okay. So 250 milligrams per liter means how many moles?
Um,
250 milligrams per liter means how many moles? So 1 mole contains 100 grams. Okay. Or we can say 100 grams is equal to 1 mole, right? So 1 gram is equal to 1 by 100. Okay. So here we have 250 milligram, right?
2.5.
Is it 2.5? So is
So
it
you said 100.
0.25? It is 0.25 grams, right?
Uh,
0.25 grams. So 0.25 by 100 moles, right? It is 0.25 moles. Now, so So if I write that in molarity, it will be 0.25 per moles per liter. 0.25 moles per liter, right? Is it is it fine? Are you able to understand?
Sir, if you just break this down from the beginning and again.
Okay, okay, okay. Just start again. So we have 250 milligram per liter, right, of calcium carbonate. So we have to find out how many millimoles per liter are there. Okay, so 1 mole corresponds to 100 grams of calcium carbonate, right? So we can also write it as 1 mole corresponds to 100 into 1000 milligram of calcium carbonate, or we can write
Yes.
this much milligram of calcium carbonate, okay, per liter will be equal to 1 mole
Mole.
per liter, right? So now we have 250 milligram per liter, right? So it will be equal to 1 by 1 minute. So we have 250 milligrams per liter. So it will be around 2.5 millimoles per liter. Okay,
Yeah.
is it fine? Others are able to understand?
So you've said 1 mole equals to 100 grams of calcium carbonate,
Yes,
and 1 mole equals to 100 times to 1000 of calcium carbonate. That is 100 with 3 zeros of,
yes,
let's say, liter grams per liter equals
yes,
to 1 mole per liter. So we have 250 milligrams per liter, and we wanted to convert this into milligrams, millimeter per. Now, okay, this me. So milliliters.
no,
Okay.
millimoles per liter, I am saying.
Yeah, millimoles per liter. So if 100, no,
What is the confusion? Just tell me.
yeah, there's no confusion because you said 100,000 milligrams per liter equals to 1 mole per liter. Then we have 250 milligrams per liter. How much is this
Yeah,
in moles per liter? We
yeah.
just multiply 250 with, no, do we multiply it? We
I'm not
should
understanding
divide
your problem.
250. Yeah, it's clear. Like we have 100,000 milligrams per liter equals to 1 mole per liter, and now we have 250 milligrams per liter, and we want to know how much this is in millimole per liter.
Yeah,
We definitely have to divide 250 by 100,000.
yes,
Is that right?
yeah.
So
Or
with
else
that
we will just,
250,
yeah, we will just go by some other. So suppose we have 250 milligram per liter. Okay, so that
yeah,
correspond to 2.5 moles, right?
Yes.
because one
Yeah.
mole is uh, uh, 100 gram per mole. Okay, 1 mole is 100 gram per mole. Now, since they are asking in millimoles, okay, but actually we have 250 milligram per liter. So that will be equal to 2.5 millimoles. Millimoles. Is it fine? So instead of
Yeah.
250 grams per liter, we have 250 milligrams per liter. So that is 2.5 millimoles. So the molarity will be 2.5 moles per liter, or we can write 2.5 millimoles per liter. Millimoles per liter. Okay, millimoles per liter. This is, I think, easier to understand.
Yeah.
Is anyone else is having any doubt?
No, sir.
No, sir.
Okay, so this is, I think, easier to understand. And before that, other equivalence term, is everyone clear how to get the equivalence thing?
Yeah, it's clear till that point you find the molecular weight of that calcium carbonate was 100 and the equivalent weight was 50. So you've changed it to millimole per weight.
Yeah, so
Yeah.
here for equivalent weight, you have to careful, you have to divide with the combining capacity. So these thing changes
Yeah.
according to the question. So you have to be careful about the combining capacity. Somewhere it is the charge, somewhere it is the valency, or somewhere it's the number of electrons or protons that has been donated. Okay, so for calcium carbonate directly, uh, we can see like it is Ca2 plus and CO3 2, like CO3 2 minus. So here the charges are
Yeah.
2. So we can directly divide by 2.
Two.
Okay, so once we
Two.
get the equivalence per liter, then just simply divide with the concentration that has been given in the question. So 5 milli equivalent per liter. Okay, so this is the tricky part here. Okay, so we'll move to the next
Yeah.
problem.
It's like okay.
Okay, so I think this is clear. So the same thing has been written here, right? We'll move to the next problem. The mass transport in advection is along the direction lateral to fluid flow, and in diffusion it is more apparent in the direction of flow. Is it true or false? So mass transport in advection is along the direction lateral to the fluid flow, and in diffusion it is more apparent in the direction of flow. False. So what should be the correct answer here? Can someone tell me? So as I showed in the last diagram, so advection happens in the direction of flow, whereas diffusion happens in the direction lateral to the flow. So that's why this is just the opposite that is written here. Okay, fine. So this is false. Advection happens along the direction of the flow, and diffusion is more apparent in the lateral directions. Okay, so this is the right answer. Now here, so in the image below, given below, each graph depicts a type of mass transport. Choose the correct option. So we have advection, diffusion, advection, and diffusion. So which of them is correct? Others also please try to answer. Yes, option A is correct. So this is nothing but the concentration versus the distance graph. Okay, or distance versus the concentration graph. So as I told you, in advection there is no change in the concentration. So the concentration remains same throughout the distance. Okay, be it distance 1, distance 2. Okay, everywhere the concentration remains same. Whereas in diffusion, due to the concentration gradient, the concentration changes with the distance. So that's why you can see there are two lines that are in decreasing trend. Okay. Whereas if there is advection plus diffusion, there will be some part which will be getting advected easily, whereas there will be some change in the concentration also. So there you can see a slight bend in the concentration profile. Okay, so I think this is very easy to understand. So in advection, no change in concentration. In diffusion, there will be always a decreasing trend. Okay, and in advection and diffusion, there is a mix and match. Next, after the London cholera outbreak case study, how was the water treated to control the epidemic? So how do you think the water was treated to control the epidemic? Option A.
Option A.
Yes, option A. Many of you are saying it as correctly because that time UV reverse osmosis were, I think, not very popular. Okay, so option A is correct, but it was also followed by sand filtration. So what happened is during 1854 the cholera epidemic happened. Okay, in London, and the outbreak was less severe in areas where the sand filters were installed. Okay, so you can see because the sand filters were there, the contamination of the pathogens was really less because the bacteria was removed from the system. Okay, so this was due to the contamination of sewage water, and then they tried to disinfect with the chlorine. So both chlorination and sand filtration were a part of the treatment system during the London cholera outbreak. Okay. Next problem. Turbidity gives us an idea about dissolved solids, BOD, suspended matter, or the nitrates. So here the correct answer will be only C. Okay, only the suspended matter. Dissolved solids won't impart any turbidity because, as you know, the principle of turbidity, it should be some light scattering should be there. Okay, so due to suspended matter only, that scattering will be possible. So the correct answer is suspended matter. Select the reason why we choose coliform as an indicator of pathogens. Is it due to because it is present in intestine of warm-blooded animals and humans? Is it harmful to humans? It is present in great numbers, so it can be easily measured, or it has a low survival rate. So why do we choose coliform as an indicator pathogen? So we say that these coliforms are present wherever the pathogens are also present. Okay, so yes, many of you are answering, but it's not the complete answer. So both A and C are correct because it is present in the intestines of all the warm-blooded animals and humans. Okay, so with the feces, it is also present there, and also they are present in large numbers so that they can be measured easily. Okay, but it is not harmful to humans. Okay, always remember that coliforms as such are not harmful, but if they are present, it means that the other pathogenic bacteria or microbes are also present. So that's why we use them as a indicative organism. Next, select the correct sequence for a typical wastewater treatment plant. So we have grit removal, primary sedimentation, biological treatment, secondary sedimentation, all these things. So what is the correct sequence here? So yes, A is the correct answer. So if you see the treatment system, so we have the grit removal first, and then the primary clarification happens, followed by the biological treatment, that is the aeration tank or the ASP, and then after the formation of sludge, the secondary sedimentation happens. Okay, followed by some disinfection. So the correct answer is option A. Okay. The concentration of MgSO4 in a solution is 360 gram per liter. What will be the concentration in moles per liter? I think this is very easy. Can you do it? - 3.6. No, I don't think it is the correct answer. So what is the molar mass here of MgSO4? Can someone tell me? Because to calculate the molarity, we have to know the molar mass.
DMG is 24, S is 32, and oxygen, because it has 4, so it's 16 times the 4. Sum of all of them is 64. Uh, it's,
Okay, so what is the total?
so 24 plus 32 plus 46 is 120 grams per mole.
Yes, yes. So what is
And molarity is the grams per liter per molar mass. So you've given us 360,
yes,
and the molar mass we find 120. So 360 divided by 120 is 3.
yes, yeah. So MgSO4, you can write it as 24 plus 32 plus 64. So we have 120 grams per mole, right? So the molarity will be 360 milligram per liter, oh sorry, gram per liter divided by 120 gram per mole. So it is nothing but 3 molar. Okay. So similarly, that last problem also we can do. So it was given like 250 milligram per liter, right? 250 milligram per liter. So if I want to convert it into gram per liter, because we define molarity or anything, so 250 gram per liter by 1000, but we want the answer in millimolar. So that's why it will be multiplied by also 1000. Okay, so these things will
Yeah.
cancel. And in 1 mole, we have 100 100 gram per mole. We have 100 gram per mole, right? So the answer will be 2.5 millimolar per liter. I think this is much easier to understand, the last one.
Yeah.
Okay, right? So 250 milligram per liter, we are writing 250 by 1000. but we need the answer in also millimolar. So we will multiply by 1000 and divide by the molarity. So it is 100 gram per mole. So it is 2.5 millimolar per liter. Millimoles per liter or 2.5 millimolar. You can just write 2.5 millimolar. Right? So these type of conversions are little tricky. So you have to, okay, I have shown the answer already here. Sorry. So this is another example where we have to find out the concentration as CaCO3. So most of the time, you know that hardness concentrations are indicated in terms of milligram per liter as CaCO3. Okay. So how to convert it? Uh, okay. So it's very simple. You just have to first find out the equivalent weight of that substance. So here it is given as calcium. So equivalent weight of calcium will be molar mass by combining capacity. Molar mass of calcium is 40, and since a plus 2 charge, so 40 by 2. So we have 20 gram per equivalence. Now the equivalent weight of calcium carbonate, because we have to convert in terms of calcium carbonate. So it is 100 by 2 as we have seen earlier. So it is 50 gram per equivalence. So now the weight of calcium as CaCO3 will be 200 by 20 into 50. Okay, very simple. So it will be 500 milligram per liter as CaCO3. Is it clear to all of you? If you want, I can write it and show you. Do you want me to write it? Okay, I think it's clear. We'll move forward. What drives the process of diffusion? Bulk motion of fluid, concentration gradient, transport by wind, or spreading of substances? B. We have discussed this enough. So concentration gradient is the driving force of diffusion. Okay. It is the driving force of diffusion. Another question. What is the mathematical expression for Fick's first law of diffusion? So what is the mathematical expression for Fick's first law of diffusion? So it is just a formula that you have to know. Any idea? So diffusion means there will be a concentration gradient, right? Okay, concentration gradient is there. So concentration is gradient is with respect to space, always remember. So actually Fick's first law of diffusion, it says that the molar flux, okay, molar flux, we will discuss all these things in detail in the next class, but just to give an idea, the molar flux J is directly proportional to the concentration gradient. So we did show concentration gradient as dc by dx. Okay, so with respect to space, how the concentration is changing. Okay, so J is directly proportional to dc by dx. So if we remove the proportionality, we need to add a constant as we have learned earlier in the lower classes. So that constant is actually d. Okay, it is also called as diffusivity constant. So it is d dc by dc dx, d dc by dx. But we know that the concentration always in diffusion decreases, as we saw the graph. Okay, in the previous problem, the concentration decreases with time. So that's why there is a negative sign also. Okay, so this is first law of diffusion. So the molar flux is proportional to the concentration gradient. When we remove the proportionality constant, there is a diffusivity coefficient being added. And since it is always decreasing, we will add a negative sign. Okay, so I hope this is clear. Okay, another simple problem. Hydrochloric acid reacts with sodium hydroxide in 1:1 molar ratio to produce water and sodium chloride. Okay. A solution contains 30 milliliter of 0.5 molar HCl. Determine the volume of 0.5 molar NaOH solution needed to completely neutralize the acid. Okay, so this is just balancing the equation and finding out how much volume of NaOH is required. So here hydrochloric acid is reacted with sodium hydroxide to give water and sodium chloride. So can someone tell me the answer? It's very simple. Shall I go ahead and solve it?
Yes.
Yeah. Okay, so it says that this is a very simple equation. It says that hydrochloric acid HCl will react with NaOH, right? And it will give sodium chloride, that is NaCl plus H2O. This is the basic equation. Uh, yeah, this slide will be shared by the NPTEL team. Okay, so weekly the recorded lecture, whatever we are discussing now, it is getting recorded, and this recorded lecture will be shared with you, right? And also the PPT will also be shared. So don't worry about it even if you miss the class, but I would request all of you to please be available for the class so that you can actively discuss and ask your doubts. Otherwise, it won't be possible in any other time. You can always mail me, but I would request you to please actively join the classes so that we can discuss and whatever problems are there, we can solve it then and there. Okay, so coming back to the question, it says that, so first in these type of question, first write the equation, okay, and see if it is balanced or not. So here if you see, it is all balanced. There is no point of adding any coefficients because two H are there in both sides, one O, one Cl and one Na. So it is well balanced. So we can see that 1 mole of HCl is reacting with 1 mole of NaOH, right? As per the equation. Now we have to find out the moles. So in the question, it is given that we have 30 ml of 0.5 molar HCl. Okay. So how many moles of HCl of we have? How many moles of HCl? So it would be, so 0.5 molar means 0.5 mole per liter, right? Into how much volume is there? We have 30 ml, so we can write 30 by 1000 liter. Okay, this liter will cancel. We will get it as 0.015 moles. Okay, so we have 0.015 moles of HCl. Now we know from this equation that 1 mole of HCl react with 1 mole of NaOH. So 0.015 mole of HCl will react with 0.015 mole of NaOH. Okay, now in the question, it is given that we have 0.75 molar NaOH. So what will be the volume? Very simple. So we have 0.015 mole of NaOH, which is equal to, we will some x into 1 minute. Some moles, some molar, 1 minute, 0.05 moles of NaOH into the volume will be the molarity, right? Will be the molarity. So my volume will be equal to, molarity is 0.75 divided by the number of moles. I think something is, I think 1 minute, just a second. I think I have written it in reverse. Okay. So number of moles divided by the liter is the molarity, right? So 0.015 moles by m will be the liters or the volume. So my volume will be equal to 0.015 moles divided by 0.75. So volume will be 0.02 liters or 20 milliliter. Okay, I wrote it in the other direction. So this is how the question will be. So 20, so we need to add 20 milliliter of 0.7 mole of molarity of NaOH. Is it clear? Is it fine for everyone? Any doubt? I need you people to respond, please, or else I will. Okay. If you have any doubt, please let me know. Very simple. First, write the equation, see if it is balanced or not. Okay. Then this is given in the question. So we know 1 mole of HCl will react with 1 mole of NaOH. So we will calculate how much moles of HCl we have because we have the all information of HCl. So we have 0.015 moles. Now this will react with again 0.015 moles of NaOH. Now we know the basic equation that moles per liter is molarity. Okay, so if we just rearrange the equation, so the liters or volume will be equal to moles by the molarity. So that will be equal to 20 ml. Okay, so this is how we have to do it. Okay, so going to the next. So I think that's it for today. Uh, these were the questions that I wanted to discuss for today, and we will meet again in the next Tuesday from 7 to 9 p.m. And I have shared my email address also. If you have any doubts regarding this week's lectures or any other thing related to this course, you can just drop a mail to me. Okay, I will try to respond as early as possible. So that's all from my side for today. You can leave the session if you have no more doubts, or we'll meet again in the next week. Thank you. If someone has any question, you can ask me right now. Yeah, thank you. Thank you, everyone.